If you recall, yesterday we were interpreting the derivative, and our interpretation of the derivative was tied to our interpretation of slope, because the derivative is telling us the slope. So the way we interpret the derivative is going to be the same as the way we interpreted slope. So the units of the first step is to write down the units of the slope or the units of the derivative. And the units of the slope are there right in the title. Change in y divided by change in x. Take the units of y per units of x. When you do that division, you're finding out how much y changes when x increases by 1. That's what happens when we simplify that. We say, what happens to y when x increases by 1? So step 1, write down the units of the slope. Write down the units of your function, then write the word per, and then write the units of your input. Then we think instantaneous at a point. We just take that and interpret it as an instantaneous rate of change at a point. So at this moment, this is our speedometer reading. So at this moment, instantaneous at a point, our favorite example, speedometer. Or speedometer. We have an average rate of change when we have a delta y over delta x, but what our speedometer is doing is not actually just a slope. It's not just a slopeometer, it's a derivativeometer. It's giving us our instantaneous rate of change at that moment. It's actually approximating the instantaneous rate of change, but it's telling us the instantaneous rate of change at a particular moment. So we just need to think instantaneously at a point. And what we're thinking about here is when we have 0 divided by 0 is equal to what? It's really weird to not to say 0 divided by 0. We can't write that down. It's indeterminate. We can't figure out a 0 over 0. But that's what we're doing. We're figuring out a 0 over 0. So the story is like, oh, we can't just divide by 0. And then people will be like, oh, come on, man. What's 0 divided by 0 in this case? And it's like, all right, let's do some derivatives. Because that's what we're doing. Now, this goes back to our original principles that on that first day of class. What do we do to make 0 over 0 not just undefined? That's an important thing to keep in mind and get reminded of every now and then. What do we do? This is kind of the calculus question. This is the calculus way. I want 0 over 0 to be something more than just undefined. Undefined bails on the problem, not acceptable. And this happens a lot in math. Like we're like, oh, the square root of a negative number, that's not a real number. And then we just didn't just leave it there. Like I was there. We don't just leave it there. We say, well, what if it is something? Does that lead to something consistent that we can study and analyze and use in other areas? And that's the same thing that happens here. 1 divided by 0, that's just undefined. It's all kind of bad. But 0 over 0, that might be something. And so that's what we're doing in this case. Remember what we're looking at, what we use to calculate the 0 over 0, to calculate this delta y over delta x when both of those are 0, is we use an approximation where delta y and delta x are close to 0 and then try to figure out what's going on. We need to determine the conditions under which we can use the discrete to approximate the continuous. So we're trying to define the terms under which we will use the discrete to describe the continuous. We're trying to determine the conditions and the rules under which we can use the discrete to describe the continuous. We're trying to determine the conditions and rules under which we can use the finite to describe the infinite. Let me break off my articles very well. This is what our limit rules are about. They have definite answers, and we know how to perform these calculations. But there's a gulf between the discrete and the continuous that we are just ultimately approximating. We're getting a feel for it. We're getting a sense of it. This rigorous thing that we have to have rules for and conditions for, we're still just trying to get a feel for this rigorous thing. We're trying to develop an intuition for this rigorous thing. Other things that look like this, what we're trying to do with math, what we're trying to do is model the world we see around us so that we can analyze the world that we see around us. We're trying to create a model for what we observe so we can analyze and understand what we observe. We're building a model for what we observe so that we can build an understanding and analyze what we observe. When I say this out loud, it always feels super obvious, but I decided a long time ago, just say the obvious thing. If nobody in the room needs to hear the obvious thing, then you really haven't spent that much time on it. But what if someone needs to hear the obvious thing? Because every once in a while, we need to hear the obvious thing. So we're building a model for what we observe. That's the point of what we do in this math stuff. We're building a model for what we observe so we can understand what we're observing and so we can analyze what we're observing. Make improvements, think around the edges and all that. The tricky part is that what we're observing sometimes is a continuous thing. We're observing this continuum and we're collecting data on it, and the data comes into us discretely. We're getting this discrete picture, this low resolution picture of a continuum. So when we're collecting data, it's like we're getting a low resolution picture of a continuous thing. It's like when we see something with our eyeballs, we are seeing curves and round stuff. And well, I don't know about you, but I see blurry stuff, but it's like round and stuff like that. I see blurry stuff. When we look at a picture on some screen, we're seeing a bunch of dots. And we're using our brain to make those dots look like curves, but it's just a bunch of dots. The computer is actually not drawing a curvy line. If we look close enough, we can see that it's just an approximation of some curvy line. And so we're trying to decide what conditions and under what rules is that discrete description good or not. And that changes over time, right? Because our resolution is much better now. It used to be that when we had a screen, we had to decide what to do because is this an O or is this a 0? Because we only had one way to represent it. Because we only had like 5 by 6 block of pixels to describe all of the letters. And so for a long time, if you might find people my age or a little bit older than me that write 0 with a slash through it. You don't see that anymore. But some people are like, oh, this is 0. And this is terrible. Don't do this. Don't be like, oh, I'm going to look all old school. I'm going to start slashing my zeros. It's like, oh, no. If you do this, I will just take off an inordinate amount of points. It's like, oh, the empty set is not an integer. It was for a while because if you were my age or a little bit older, computers couldn't distinguish between an O and a 0. Now we have lot better resolution. So when the computer displays an O, you're like, oh, that looks different than a 0. You can even tell the difference between an uppercase O and a lowercase o and a 0, right? The fonts all look different. But back in the day, we had to do this, but the empty set is not the digit. That is definitely one thing I'm not nostalgic over. When I first started teaching, whenever I had older students, I go, oh shit, there's going to be someone that's going to slash their O's, and I'm going to have to be a dick about it to try to cure them of that. But before, to make an O, it was all you had was a bunch of boxes. That's what the computer could display. And you could see each individual box. It's like on your TI-84, you could see each individual pixel. On your iPhone's like, oh, you can't see my pixels. But on TI-84, you could see the pixels. On your Game Boy, you could see the individual pixels. On your Nintendo Entertainment System, you could see the individual pixels. My favorite thing is like, you know, like when Mario was running around on the NES, you know how it was like flashing a little bit? That's because you weren't looking at Mario and the turtles at the same time. It was just alternating because it couldn't display them both at the same time. It's like, oh, that's too much. We're just going to alternate. That's why it looks a little bit flashy. Anyway, so to make a 0, we're like, oh, we'll just color in the outside for an O, right? Here's an O. I don't know why I thought I had to do this much detail, but I thought it was fun. And like, all right, there's an O. Then we came to like make it more. It's like, oh, no problem. We programmed the O. We're all good. We got to make a 0. Fuck. Now what? And then we're like, oh, some computer dudes are like, oh, let's just put a slash through it. There we go. There we go. That's a 0. And everybody high-fived each other. We all went to lunch. And then there's a whole generation of people that be putting slashes in their O's. We're generally cured of that now. I have it as A. Some people still write in all caps, though. That's actually another thing that's going away. People, does anybody know anybody that writes, like handwrites in all caps? That's a thing that's generally going away. And why is that? Because we've evolved. We started getting email. And when we wanted to be mad in the email, we put it in all caps. And so now if you write all caps, you're shouting. Like modern eyes, younger people's eyes, see all caps and like, oh, dude, why are you yelling? We've evolved. See, email has cured us of writing all caps. So now generally the only people that are writing in all caps are like architects and shit like that. So, but now no one does that because it's like, oh, why is this so loud? Stop shouting. And so we've gotten away from that. You know what I mean? It's kind of like the cursive thing. It's good that cursive has gone away. That's a good thing. That's an advancement in the society, that we all have access to typing things, so we don't have to learn to read each other's handwriting. We don't have to learn to write all the same, so that we have to read each other's handwriting. I don't know why I still like stuff. I guess it's just because I'm an old person. You know what I mean? Anyway, all beside the point. The big thing that we're going for in calculus, like I said at the beginning, is that calculus is about thinking about infinity and making rigorous the idea of infinity, which is weird in and of itself because infinity is not just a number. It's this weird concept. And it does weird things. So we have to come up with some rigorous ideas so that we can see a continuum and describe it with a discrete set. We have to know when we can approximate 0 over 0 with really small divided by really small. When does that become good enough? Because the question came up at the beginning when I said we move the points closer until we see what's going on. When the question comes up, how will we know we've got close enough? And the answer is, you'll just know. You have to keep doing it until you just know. Any questions? It's a big challenge when you're trying to learn stuff. It's nice to be able to learn stuff by just breaking it down into steps. People say that all the time about fucking math. It's like, well, just break it down into steps. The problem with just breaking it down into steps is that it usually stops at breaking it down into steps. You can't stop at breaking it down into steps. You can start with breaking it down into steps, but you can't end there. You break it down into steps so that you can develop a feel and you can develop an intuition. Think about driving here today. How much do you turn the wheel to make that turn? How much would you turn the wheel? How many degrees do you turn the wheel through to make that turn go around that drop-off point? How many degrees do you turn the wheel? Does anybody know? But anybody with a license, if I actually make a turn around to drive your car around that circle, you'd be fine. You'd be able to do it. Some of you would do it with a little more panache than others if I took the restrictions off. You're like, well, I have a rear-wheel drive car with lots of power and shitty tires, so I am going to slide around it. And I'm like, oh, that was cool, but knock it off. But you can't tell me how far you turn the wheel, right? It's not a bunch of steps. You just have to know. How will I know how much to turn the wheel? You'll just know. Any questions? You all are quickly getting away from the part of your math history where you can just look at a bunch of steps and copy what you see. That goes away. You have to start feeling what's going on. You have to start understanding what's going on, not on a mechanical level, step 1, step 2, step 3. Although when that happens, we're super happy. We're like, oh, good, that gives us a good place to start. But you have to start developing a sense of what's going on. The nice thing is that it happens kind of subconsciously. It's like it just happens. A lot of you have a very good feel for algebra, not a mechanical step 1, step 2 for algebra. You have a sense of what goes on in algebra, which is cool. Any questions? How's everybody okay? Other than that, it's just about reading everybody else's shorthand. Math is ultimately a reading exercise that you feed into your intuition, just like any other language, just like any other language. Here's one of my favorite examples of just like a reading exercise. This comes up every once in a while, not this particular problem, but this is an order of operations question. Order of operations. Let's see. Take a moment and evaluate this expression for x equals 3 and y equals 2. Invisible timer. We've got a value. What do you got? 2. Does anybody have something other than 2? How many people just refuse to answer the question because it's clearly meant to be misleading? Can anybody just like say no? Okay, so one person got this problem actually right. Refusing to answer the question. Like, now, Leach, I think this is a trick question. Trick questions are bullshit. I refuse. Like full marks. That's the only way to get. I don't know how to make that on Canvas happen on Canvas, where you have to leave it blank to get points. Like if you answer anything, you lose points, but if you leave it blank, like the Zen answer, like the only correct answer is not to answer. Well, I can't throw one of those cool pioneer mustaches. Yeah. Correct. That's absolutely correct. The way that you interpret this, because other answers that we might get are 5 and also 6/7. What I'm saying is that how you, which of these 3 you come up with is entirely cultural. It's how you were raised. We try to make people all be raised in the same way, right? We try to make everybody, it's like, oh, we want to put everybody on the same page. Let's make a culture where we put everybody on the same page. How many people put 2? How many? 2, right? Because 2 times 3 is 6. 3 times 2 is 6. 6 divided by 6 is 1. Plus 1 is 2. How many people put 2? Would you put 2? Did you read that with a strict reading of the order of operations, PEMDAS for did you do that? Do you come up with 2 if you perform a strict reading of PEMDAS? Clearly the answer is no. Culturally, when we see 2x over 3y like this, the 3 and the y are together. For some reason, that multiplication takes precedence over the division that's right before it. A strict reading of PEMDAS is 2 times x divided by 3, then multiply by the y. But culturally, that's not how it works. The 3 and the y are together. That is one factor. That is one factor. It's literally 2 factors, but we read it as one thing. So what we're reading, we get 2 if we read it as 2x divided by 3y, and then this plus 1 is separate from that. A strict reading of PEMDAS for the 5 is 2x divided by 3 times y, because it's like, oh, no, you didn't say divided by 3 times y in parentheses. Oh, strict rules, strict reading. But the strict reading is bullshit. No one comes up with 5 unless you know what I'm planning on doing. And you're like, oh, I'm going to fuck with Leach and put 5. because I know he's going to expect me to do that. Then, depending on what your algebra upbringing was like, maybe you look at the divide by 3y and you say that 1 is clearly supposed to be part of the denominator. And so you interpret this as 2x over 3y plus 1, which leads to 6/7. Now we can make clear on a single line which one is which, right? I would just have to say 2x divided by 3 times y plus 1, or switch colors. What haven't I used? Purple. 2x divided by 3y plus 1. So we can make clear specifically which one, but if you're going to be asking this question, you need to take into account who you're talking to, because we might all have different algebraic experiences. But yeah, it depends on the time. At some point we tried to standardize it, but the standardization never takes. You can never standardize something in one place. It's very rare that that works and everybody just agrees to it. I mean, we got this 10-digit thing. I don't know who put that shit on us. 10 is terrible, by the way. I'm like all anti-10. We should have been base 12, like right from the start. It's too late to fix it now, just like pi. It's too late to fix pi now. It's too late to fix base 12. It'd be a disaster. It'd be like, oh, nope, everybody around the world has to drive on the left side of the road now. There's just going to be like massive amounts of deaths in countries that are driving on the road. You know what I mean? Anyway, I don't know why I thought of that. I don't know where that came from. The point was, we are talking about interpreting the derivative. You need to be able to interpret the derivative. It's just it starts with writing out what the units of the slope are. The units of the output, write per, then write the units of the input, then interpret that instantaneously. Interpret it as a 0 over 0. Don't say out loud that you're thinking of 0 divided by 0, because people will be like, oh, that's not okay to say it that way. But now that we're this far in calculus, we're all cool enough to be like, oh, it's like a 0 divided by 0 is sometimes 0, and sometimes a constant, and sometimes infinity. It depends on what kind of 0 over 0 we're doing. We're all sophisticated enough to say shit like that, right? We've all advanced far enough. We've crossed over into the land where we can't just like immediately have to say, nope, it's undefined. You know what I mean? Here's why I don't like it when people say, well, in a math class, there's always just one right answer. Oh, that's what I like about math. You know, the only people that say that? People don't know shit about math. That's like the clearest indication that you don't have a lot of math background. Well, there's always just the one answer that we're going for. The answer in a math class, when you're learning math, is the least important part. It's just the one that we all aim for, so that when I look at that, I'm like, oh, okay, things have gone well, because you've got the right answer. Then I look at the rest of your work and say, yeah, things have gone well. When the answer is wrong, it's like, oh, something has gone wrong. Then I have to look at your work and say, what was that? That makes sense? That's what I want you to think about while you're walking around. That's your homework for this weekend. To think of your perception and how we observe things that are continuous discreetly, not subtly, like not fortunately, but like we take in information like of this continuum, like that car that just drove by. And if I took film of that car going by, it wouldn't be a smooth car going by. It wouldn't be a continuum. It took about a second. It'd be like 24 individual pictures that my mind just bleeds all together. Or, since we're in a modern age, 30 pictures where my mind just bleeds all together. Or some of you have enough money, 60 frames where your mind just bleeds them all together. But it is still just 60 pictures. Any questions? That's what I want you to think about. There is this gulf between the discrete and the continuous. We have to know when we can use the discrete to model the continuous. As far as the answer for when we can do that, there isn't one clear picture. We're creating the model and the thing that we're trying to model are separate. And we push them very close, and yet they're still infinitely apart. Math is weird, I guess, is my point. Any questions? I know today was a little bit weird, but I had a meeting like right before this, which was a project on like a zero cost textbook. I'm like, why don't we just buy the textbook for the students? And I thought, no, not like that. All right. You know what I mean? Like, you know how Skyline is free this semester? It's like to get you hooked, and then like in later semesters, we're going to start charging you or something like that. Free is just the starting point. Free, I've said this before, but it bears repeating. Free is too expensive. Free is still too expensive. The people that can afford free are the people that still have to be able to afford to like live. So even by making college free, you're making it less exclusive, but it's still exclusive. You're still attempting to exclude people from the process. And at the same time, telling people, you should do this process. We'll all benefit if you do this process. So you'll help us with this? No. Think about that when you're in positions of power. Because someday some of y'all will be, and I want you thinking about that. Now, if you think I'm wrong, 100% okay. But don't disagree with me simply because everything has to be profitable and everything has to be money, and you've always been told this. Always say, what if not this? What if not this? That's it. At the end of your college career, my greatest hope is that you have infinitely more questions than when you started your college career. When you were 14 years old, that is the last time you should know everything. 14-year-olds just think they know everything. That's the shit that happens. The further you go, the more you need to realize you don't know. When you graduate, have more questions. Any questions? You guys are already fucking it up. I said, have more questions. I'm like, oh, are there any questions? You had none. Oh, I'm just kidding. Now would be too soon. It takes a while to generate questions. Anyway, this is what I want you thinking about. I want you thinking about this calculus. Every time we do stuff in calculus, we're modeling the continuous with the discrete, and we're just coming up with rules when we can do that. I wanted this thoughtful reminder because we've been doing a lot of mechanical shit that is helpful, but not helping us think about stuff. That's going to do it for today. I know it was very thinky today, but it's Friday. What the hell? That's it for today. I will see you all on Monday. Everybody have a good weekend. Thanks for playing.